is solving problems using tables and diagrams. I like this section. I think you will too. And I think you'll like this video as well because it's going to be pretty quick. So, just like the title looks like, we're going to solve some probability problems using tables. That'll be the front side. And then using tree diagrams. And we'll do 2 of those on the back. So here we go. First question. Students have been asked to vote on a night for the Christmas dance. Right, whether to have it on a Wednesday, a Thursday, or a Friday night. The following table shows the results. So we've split the results into males and females. This many kids said Wednesday, this many said Thursday, this many said Friday. So the first thing we have to do is complete the totals. So how many kids said Wednesday? Well, 24 and 32 is 56. How many kids said Thursday? 35 and 28 is 63. How many said Friday? 94. Now I've also got totals here. How come? Because this is the total number of males and this is the total number of females. So how many males are there? Well, 50 and 35 is 85, plus another 20 is 105, plus the 4 is 109. And for the girls, 32 and 28 works out nicely to 60, plus 44 is 104. Okay, we're left with this one space here, this box, total. If we add this, we get 213. If we add this way, guess what we get? 213. Try it if you like, but you'll see you get the same both ways. Okay, how many students voted? 213. That's our total. So 213 students gave their opinion on this. Determine the following. The probability of one of the students being female. Well, how many females are there? 104. How many students are there total? 213. So there you go. The probability that any random student who voted as female is 104 to 213. You should put all these probabilities in lowest terms. In this case, 213 I believe is prime, so they're all going to be in lowest terms. Isn't that nice? Oh, if it's the total amount we're looking at. In this case, we're not. What does this mean? This is the probability of a student picking Thursday if the student was male. So this is conditional probability. So if the student was male, in other words, we're only going to be looking at this top row here. So if a student was male, if that's already a given that a student's a male, what's the probability they pick Thursday? Well, if a student was male, we're only looking at the top row, 35 students pick male, and the total number of males is 109. Here's another conditional probability. It looks almost the same, except it's the opposite way around. This time, what's the occurrence that's already taking place is that it's a Thursday. So we're being told that the student chose Thursday. So if a student chose Thursday, in other words, it's in this column here, what's the probability that they're male? There were 63 kids who said Thursday. What's the probability that it was a male? Well, there's 35 males out of 63 total. Okay, so order is important when you're looking at this. What's the probability that there was a female and Friday? So which one of these squares is female and Friday? It's this one right here. This is the female and Friday square. And so we have 44 people who were female and picked Friday out of a total number of students 213. Determine the probability that a female student chooses Thursday for the dance. So this is another conditional probability. This is kind of like what we did here, except this time it would be female. Given that it's a female, what's the probability that they pick Thursday? So we're only looking in the female column here, or female row. We're looking at this row, and we want to know what the probability is they chose Thursday. Well, 28 females chose Thursday. How many total females are there? 104. So it's 28 out of 104. Now this one we can definitely put in lowest terms. Divide by 2, you get 14 over 52. Divide by 2 again, you get 7 over 26. That'd be your answer. What's the probability that a student who chooses Wednesday is male? So again, this is conditional probability. If it's a given that the student chose Wednesday, what's the probability that they're male? So student chose Wednesday. So this is the only column we're interested in. It's a given that the student chose Wednesday. And what's the probability then that they are male? Well, 24 males picked Wednesday. How many total people picked Wednesday? 56. So 24 to 56. And again, we could put that in lowest terms, divide them both by 4, you get 6 over 14. Oh, we can also divide by 2, you get 3 over 7. I guess I could have divided by 8 there. And that is the end of the first side. Okay, we're going to use tree diagrams for these questions, and this first question involves independent events. Okay, just when we get down here, we'll be dealing with dependent events. But the strategy is pretty much the same in both cases. So let's look at the first one. Teddy has 2 pairs of black shoes and 3 pairs of brown shoes. He also has 3 pairs of red socks, 4 pairs of brown socks, and 6 pairs of black socks, period. If Teddy chooses a pair of shoes at random and a pair of socks at random, what's the probability that he chooses shoes and socks of the same color? Okay, there's a lot of information there. So we're going to use a tree diagram. The way we start with a tree diagram is we put a dot. Now, the first thing we're going to look at is the shoes, right? As Simone says, shoes, shoes. That's whenever she wants to go out. 5:30 in the morning, I'm like, go back to sleep, Simone, go back to sleep. Shoes, shoes. Okay, anyway, so Teddy has 2 pairs of black shoes. So you could do it this way. Don't do this. This isn't a good way to do it. But you could put, okay, 2 pairs of black shoes. So black and black. And 3 pairs of brown shoes. 1, 2, 3, brown, 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 like that. It would work. You could do that, and then you could look at each shoe after that and look at the socks. It's not the fastest and not the best way to do it, I would say. If you think about it here, how many different situations are there with shoes? There's black shoes and there's brown shoes. So that's what we're going to do. We're going to put black shoes. We're going to put brown shoes. Now, are we just as likely to pick black shoes as we are brown shoes? No. Teddy only has 2 pairs of black shoes, but he has 3 pairs of brown shoes. That's 5 pairs of shoes total. So the probability of him picking black shoes is 2 to 5. The probability of picking brown shoes is 3 to 5. Great. So that's the shoes. Now we're going to look at socks. Let's do the same sort of thing. He has red socks, brown socks, and black socks. So we're going to do 3 lines from each of them, and we're going to write red socks, brown socks, black socks, and of course we have to do the same thing down here. And again, are each one of those socks just as likely as the other? No way, because we have 3 pairs of red, 4 pairs of brown, and 6 pairs of black. So it's a total of 6, 4, and 3 is 13. And we have 3 pairs of red. So there's a 3 out of 13 chance for the red. For the brown, it's a 4 out of 13. Hard to read that, but that's 4. I don't know what's wrong with my 4s tonight. And for the black ones, it's 6. 6 out of 13, 6 out of 13. Great, we have it all set up, and what we want to know is what's the probability that he chooses shoes and socks of the same color? So which one of these things have shoes and socks the same? This is black red. This second one is black brown. This one here is black black. Hey, that's it right here. This is one of them that we're interested in. Brown red, brown brown. Here's the other one we're interested in. Brown black. So there's 2 cases we're interested in. The first one is where you pick black shoes and black socks. Now the probability of picking black shoes is 2/5. The probability of picking black socks is 6/13. These are independent events. So what do we do to get the probability of that? We multiply them. So we have 2/5 times 6/13. Now this will give us black and black. Or the other way we could get the same colored shoes and socks, or, so that means plus, we could pick brown shoes, there's a 3 out of 5 probability of that, and, right, and, so that means multiply, brown socks, there's a 4 out of 13 probability of that. Great, we do this, we're done. 2 times 6 is 12, 5 times 13 is 65, 3 times 4 is 12, 5 times 13 is 65, already have common denominators, I love it. You get 24 out of 65. There's a 24 and 65 probability that Teddy will pick the same colored shoes and socks if he picked them at random. And that's really real life, isn't it? To be picking your outfit at random. maybe not. Okay, last question. This is a dependent one. Jack wakes up late on average 3 days in every 5. Hey, I think I teach Jack. If Jack wakes up late, the probability he's late for school is 9 out of 10. That makes sense. If you wake up late, it's very probable that you'll be late for school. If Jack does not wake up late, the probability he's late for school is 3 out of 10. That's still probable, isn't it? I know some of you do that. You don't wake up late, you wake up right on time, you still manage to come late for school. It's unbelievable. Anyway, on what percent of days does Jack get to school on time? So we're doing another tree diagram. What are we first of all looking at? Like, what are the two things that are happening? One thing is whether he wakes up late or not. So late, or wake up, I guess wake late, I'll put. That's terrible, but wake late. And the two possibilities, the two outcomes are, how should I write this? I'll put late, not late. Are they just as likely as each other? No, they're not. If he wakes up late on average 3 days in every 5. So there's a 3 in 5 chance he wakes up late. There's a 2 in 5 probability that he doesn't wake up late. The next thing we have to look up is late for school. Late school. And again, there's two things in each case. He could be late for school, not late for school. He could be late for school, not late for school. Now this is dependent, so you have to look back at this. If he was late for school, if he woke up late, so that's up here, the probability he's late for school is 9 out of 10. So he woke up late, there's a 9 out of 10 chance he's going to be late for school. So what's the probability he's not late? 1 out of 10. Has to add up to 10 out of 10, right? Has to add up to 1. So 9 out of 10, 1 out of 10. If he didn't wake up late, there was a 2 out of 5 probability of that. The probability he's late for school is now only 3 out of 10. So 3 out of 10 here. If it's 3 out of 10 there, how much here? 7 out of 10. Awesome. What's the question? On what percent of days does Jack get to school on time? Late, late. That didn't work. Late, not late. He didn't end up late here. This is a good one. Not late, late. No, he was late. Not late, not late. This is the best of all. Woke up not late and got to school not late. Oh, students who are like this are just wonderful. Now, in order to get here, you had to do late and not late. So you're doing 3/5 times 1/10. Very similar to what we did above. Or the other way you could be not late for school, or that's a plus, is you could be not late waking up. We like that. And you could be not late for school. We like that too. Here we go. 3 times 1 is 3. 5 times 10 is 50. Plus 2 times 7 is 14. 5 times 10 is 50. Add them together, you get 17 out of 50. Are we done? No! Why not? It says on what percent of days? Well, we can switch this to a percent very easily. Percent means, what does percent mean? It means out of 100. So all you have to do for this to get a percent is change 50 to 100 by multiplying by 2, multiply 17 by 2, because you do the same at the top as you do at the bottom, you get 34. 34 to 100 is the same as 34%. Just over a third of the time he will be to school on time. I'll say it once again. I think I teach Jack.